Okay, let us begin our class today. I will speak a mixture of English and Chinese. Okay? So you can learn too, right?
Yeah.
Good, okay. So the first class, I will introduce what kind of control designs you are going to learn in this class. So I give you some real example. Today, what I show you here is all real sense. It's not in theory, it's in practice. So how many control techniques we're supposed to have? We're supposed to learn in this class, right? And all the notes are already in the website. And I will show you the website very soon. Just a few minutes later, I will show you where's the website. So, because the title is Applied Control, so we'll focus on the applied control, something that you can use right after you learn from this class. And also I will give you homework, about one homework per week, so you can do some exercise, a real exercise. Okay, now. Okay, now. This is Type A 101. Did you go to Type A 101? Anybody?
Yeah.
Raise your hand. Almost everybody. One. Good. How about the New York City Cop Tower? Nobody, right? Okay. I will show you two different design, how you stabilize when earthquake come in. And 101 is so tall, so high. If you happen to be on the top of 101 and also come in, what should you do? That's a good question, right? I don't have an answer for you, but I will show you. All right. Now, the outline here, the first of all, I will show you what's called tune mass damper. It is a controller design, but you don't use the electrical energy. You don't use any power. So this is what we call tune mass damper. There are two kinds of controller design. One with the one kind of control design, you have to use the power. There's another kind of design, you don't use power at all. So what would you use? What kind of control design you prefer to have? Control with the power or control without power? The simple answer, right? No? Depends on the situation. All right? We'll see. We'll see what you choose. And then the second bullet here, you can see that the slewing maneuver is called control feedback. Then I will show you some of the passive, active suspension system, real-time adaptive control, precision trajectory tracking, and so on. Many different things going on here. But this is just beginning of the class. So I'm not going to show you any equations here. Well, maybe a couple of them. But I will show you some of the video, so you can have some feeling about the class. Okay, this is called tune mass damper. If you look at carefully, this very simple design. This is your motorcycle. Anybody got motorcycles? Or anybody don't have motorcycles? You don't have motorcycle. You don't have motorcycle. That's good for you. I don't have motorcycles too. I don't want to lose my life, right, in the street. Bicycle even better. All right, if you have a motorcycle or you have a car, you do have a tune mass damper. You look at this one here. This is a motorcycle. The tune mass damper, what they do to you. Because if you ride a motorcycle or a car on an even road, then what happens? When anybody ride horse before? Anybody? Ride horse, right? It's not really comfortable. True, right? Because who damp the energy? You have 2 feet, right? That's the damper. You use your 2 feet for your damper, so you just squat and like that. So your damper is your foot. So this is the we call tune mass damper. What is the math 1? How much weight, how much mass you're supposed to have? How much mass M2 you're supposed to have? For example, M2, maybe that's your motorcycle weight, for example. Then you have spring, you have despot. You have spring and despot. The spring, why we need a spring? Do you know why we need a spring? For the motorcycle. Why? Any reason? Any answers? And why we need this despot? This we call despot. Well, we explain to you later. So this is the most basic control design commonly used in any system. Car, motorcycles, buildings, and so on. So there's a chapter in this class. We'll talk about the damper, how you design a damper so that the damper can take out the energy. I say unnecessary energy. There's some energy which are necessary, some energy which you don't need it. All right, that's the damper. All right, this is very interesting design in Taipei 101.